Hello, this is our project Defense, and the topic of our project is the burger place. We have classes menu and order that form the foundation of our project, and they are linked to the database. So they return values of food items from the menu and the order respectively. Class order also has the ability to update the database while the card is being edited. So class menu and class order use classes burger, side dish, type, and topics as objects. You can see it right here. Get toppings and get types. Each of these objects describes a separate product type from the database. Also, our program was written to be able to do the following tasks, as read the menu from the database, create cards for the orders, read the contents of the card, edit each element in the card, delete elements from the card, delete card completely, or save the card in the database. Our program applies all the core principles of OOP that are encapsulation, abstraction, polymorphism, and inheritance. Inheritance, we can see it right here. So food item has such properties as ID, name, description, and price. So we can see that burger, it extends food item, so it inherits the properties that it has. So there's ID, name, description, and price. So does the side dish, that extends again food item and inherits its properties. Also toppings right here extends the type. It's better to show the type first. Type has properties such as name and price. And toppings as it is extending the type, it also inherits the properties that type has. Then encapsulation, all the properties of the classes are declared privately. It can be modified since they are only getter functions. We can see it here as well. They are declared private, and getters are right here, get amount. We better can see getters in the food item, for example. So declared private, and the getters are get name, get description, and get price. Abstraction. It works through the abstract class food item. Again, it can be seen right here. And also we have two interfaces, menu UID. So interface has two implementations. From the first glance, it can be seen as simple, but behind the implementation, it hides all of these coding. Yeah. Polymorphism is implemented through method overloading and method overriding. Let's open menu class. That. We are looking for the new shipment. New shipment is the method that uses for lists. So it can be used with different types of classes. Here it is used with burger, also side dish, topping, and type. That is it.
So this is abstract class called food item, and that implements product UI. Objects of this class cannot be created by themselves. We can only create objects of subclasses. Since this class implements product UI, it has all of the methods. However, declaring of these methods is necessary only in subclasses such as burger and side dish. This class has such variables as ID, name, description, and price. And also it has two constructors, and one of them has ID variable because it's needed just to interact with the order. This class has only getters and there are no setters because we have changes that happen through the database. Next, we can go to the side dish class, and we can see that a side dish class extends food item. And before explaining you this row, I need to explain you what type class is. So type class implements product UI, and it has such variables as name and price, and this class is declaring them. Also, it has two getters and one constructor that initialize such variables as name and price. And we had public void display, and it displays orders, while public void menu displays the menu. It outputs the name of the type with the price of price of it. Next, we can go back to the side dish. So we have this row because it's a variable that is declaring here, and we had this name standard and price is 0 because initially if there's no side dish in the order, we need to understand that side dish will be standard and the price of it will be 0. Next, we have getter and two constructors, and it initialized the type variable. Then we have display that displays the order. It output the name of the side dish and plus with the name of the main dish, and it outputs the total price of it. And then we have the menu display that displays menu obviously, and it outputs the name and description and default price. And also we have a custom function that returns the price of the main dish with the price of the side dish. After that, we can go to the burger class. This class extends food item, and it declares such variables as meat type, and it declares objects from the topping list. After that, we have two constructors that has topping list in them. First, I need to understand to explain you what topping class is. So topping class extends type, and it has such variable as amount that initially equals to 0, and we have a getter that returns amount, and we have two constructors that initialize the variable amount. After that, we have the order display, as I said before, and it output the name of the topping with its price and with its amount. So we can go back to the burger class, and it has, as I said before, it has two constructors, and they initialize such variables as meat type and toppings. Then we have this function that find the sum of the topping and its amount. Like it multiplies the amount of the topping with its price to get the total price of topping. Then we have two getters and display function of display of order. it outputs the name of the burger and outputs the default price, the meat type, and if there's no topping, we output that there's no topping. If there's some topping, we output it one by one, and then we output the total price of it. After that, we have function of menu display that output the name of the burger, the description, and the full price and the meat type, and that's all.
Okay. This class implements a menu for a fast food restaurant by creating a database and storing items such as burgers, side dishes, toppings, and types of meat. This code uses JDBC to connect to an SQLite database and add new items to it. It has a single stored property called URL for DB, which is a link to the database. As you can see, create menu method is called in the constructor. Creates 4 necessary tables in the database if they don't exist already. For burgers, side dishes, toppings, and types of side dishes. So burgers are stored without toppings and sides without specified types, so the object can be constructed with a standard type name with an extra price of 0. The menu class implements the menu UI interface, which specifies the methods for creating and managing a menu. The menu has 5 new shipment methods. The first takes a list of burgers, side dishes, toppings, and types of sides, respectively, and adds them to the database. This method has 4 overloaded versions. Take a single item and add it to the database. These methods use SQL statements to insert data into the corresponding tables in the database. So, yeah. The menu class also has non-standard getters for the items. They work by extracting all the rows from the respective tables using result set and creating instance objects with the appropriate values, which are then compiled in lists. Menu is meant to be for the most part static, and functions in shipment, for example, are created with the purpose of initially making a database which then can be edited by an administrator. On the other hand, order class is completely dynamic. It has create, read, update, and delete capabilities. The order class also connects to the database using SQLite and link. This class gets its link through this menu, which is made a variable of the class. The order class is made to dynamically create tables for order contents, as you can see in the constructor. The order class is made to dynamically create tables for order contents, as you can see in the constructor. The constructor also says time of cart creation, but more importantly, it makes an ID integer and assigns it to the ID property of the database, which is used to create 2 necessary tables for the check, as well as read them afterwards. New cart and new cart int ID. New cart, which takes ID as function, that creates a new cart consisting of 2 tables, check ID burgers and check ID sides. If assigned ID was 1, it would be called check 1 burgers and check 1 sides, and so on. This method resides in the ID if the 2 tables with this ID already exist, so that there is an ability to create multiple checks at the same time. Then all the items from the cart are added to the tables using new burger and new side methods. They take indexes from the menu. So we can choose, for example, third burger from the menu, and it's free, and add it to the database. The burger gets added as a row, but the method also creates a separate table for the burger's toppings. They can be added from the menu into the database with a name check ID burger ID. Check ID is ID of the check. Burger ID is ID of the burger which is assigned with identity to the order. For example, the first burger in the check with the ID of 3 would have a topping table with the name check 3 burger 1 and store the toppings from that burger. We can add toppings with add topping and delete with delete topping. So the type is a singular value. So the type gets entered into the table with sites, check ID sites. It can be changed anytime you want through change type methods. But when the product gets added to the check, it's automatically added with the type standard, which we discarded earlier. We can also delete both types of products using delete burger and delete site methods, and delete the cart using cancel order. So here are menu and order classes.
Uh-huh. Since we're finished with the order, let's get straight to payment. Payment is a separate class, which creates objects that can be used to pay for the order. It's only logical that the order gets passed as an object here. It's private. It can be also declared final, so that there are no further modifications. They are not simply not needed. Uh, it's final private order, which gets assigned right here at the construction of the object. And it also has only one function called pay, which throws an exception, which to get message can be read as the order is empty. The order is empty is a function is not a function is the message from an exception that gets thrown if the total cost of the order is equal to 0. So there are no items in the cart. Then we create an amount to pay integer which is equal to the total cost to output the amount to pay. Yeah. Then we try to insert everything into a database called checks, which is created at the point of menu creation. Yeah, it is right here, actually. Create table if not exists, checks, which has ID, date, time, and total price. ID is the ID of the check. The ID of the check is assigned. The ID is assigned to the check when the check gets created through the new card functions. And the date, time, and the total are the date, which got reset here. Um, the total is the total cost. So it's like a accounting table for business purposes. Yeah. Then the statement gets closed, the connection gets closed, and it outprints that the payment is successful. If it fails to connect to the database or that something else goes wrong, I don't think it can actually, but if something goes wrong, it says that saving the check, we failed to save the check, and yeah, I think it's pretty self-explanatory. The ID is unique, so if the ID gets repeated, which I doubt that will happen, uh, it will outprint this fail to save the check. Then we go to the main. My first priority was to make sure that the main to make sure that the code was rigid and had no real exceptions or errors which would stop the code from running first and do something wrong which is not intended as the purpose of the program. First, we create, not create, just assign a variable of the path to the to our database, which is root directory /data /burgershot.db. Let's delete it for now so we can actually look at the program from scratch. Let's start this up, and meanwhile we can discuss everything that happens. First, we create a menu through the URL. Then we create an order using the menu as the passing object. And then we, just for clearance, we can outprint the ID of the order to, which is one here, to make sure that they start with one. The ID column in the table doesn't have primary key order increment, but it is convenient that the order gets assigned an incrementing variable rather than randomized or which needs to be rechecked that it doesn't exist. So it's much easier to have an incrementing variable. Yeah. Um, the order is the ID is one. Then we add all the toppings to the storage. Firstly we create everything. We create it in the program itself. They have all the necessary parts for their construction: 150, 100, 250, 500, 200, 100. Um, Burgers are hamburger, cheeseburger. I will not list them here. Let's just say everything that could be declared is declared. The types are there are four types, but actually in the menu, I think when the table for the options was created, this there was a default standard option. It comes back with the database because standard option is necessary to be returned to. We can change. For example, we got standard fries, which are created automatically, and we wanted to make them cheesy and then return them to their standard. So it's necessary to have this option at hand immediately. Yeah. So there actually are not four, but five types, and they are in order: one standard, two chili, three chili, four barbecue, and five teriyaki. Yeah. Then we got new shipment. New shipment is a function written by Slan, which consists of this version consists of four lists, every possible type, every possible um, burger, side dish, and topping. Then we browse products to show them here. Everything got added. Then we get burgers, five burgers, sides, three sides, and then we as an extra, we outprint every name of the every topping type. Uh, these are there are six toppings and five types, which one default standard and four that I've created myself. Um, then we try to add a new burger. We can add it like this, or for new product, it would look like this: new product, one, one. Because the category for burgers is one, the sides is two, and the burger is the first burger in this list. Then we try to add three toppings. Three toppings are added to the first burger, not in the menu, but right now in the chat. Since burgers are not unique, they are unique in the menu, but they are not unique in the orders, so they can be added. Um, Two burgers with the same name can be created and can be customized independent of each other. Um, the first burger is our hamburger, which was just added. Then we added cheese, which is located at index one in the menu. Three bacon, one cheese. Yeah. Then we browse and see that the hamburger is right now in the menu, in the order card, I think. It's assigned an index of one. It's a hamburger. It's toppings, the most important part, toppings are in the amount of two, in the amount of one. Cheese got added two times. First time it created a unique row in the table. Column name is made to be unique, so then it added checked for uniqueness and added a second type if when finding that cheese already existed on the burger. Then we browse then we try to delete the first topping and notice that it has a topping index of 1, but actually it is 1 not among 6 available toppings, but among 2 which are declared in the burger is 1, which is cheese. We delete this cheese to find out that the cheese was deleted and returns 1. Yeah, 2 browse products. Then we add new product at category 2, which are sites, and 3 index is chicken wings. We browse these products and see that firstly the chicken wings get added to the cart. Then we see that there's a hamburger with the same cheese one, bacon one, and standard chicken wings for the price of 1,200. Then we change the type, and actually this function doesn't outprint anything because I don't think I think it's a flaw, but okay, nevertheless, we change the type to the fourth, which is barbecue chicken. The contents of the card get changed, and they're barbecue chicken wings instead of standard, and their price is 1,400 because of the 200 markup of the barbecue type. Then we delete the hamburger. Deleting hamburger in cancel order separately is necessary to delete not only the hamburger but the table that corresponds to its toppings. Yeah. We cancel order. Then we create a new payment. Payment is created with the intent to show that the order is indeed empty, and it's indeed empty, so it outprints no items in the cart. We can also outprint something like this, e.get message, and it will actually outprint something. Let's reset the base real quick. It should outprint the same exact message of the exception. Tender chicken wings, barbecue chicken wings. Uh, okay, never mind. I think I think it's probably, yeah, the exception is not even no such item exception here. It gets more convoluted as the new array list since the get burgers is null. Yeah. Uh, let's continue. Never mind. We can control Z this. We create a new order, which is a new order which uses the menu as its menu. Uh, it the ID that is there no labels conflict with it assigning the ID of 1. Since there has been assigned an ID of 1, we can actually add everything, add this ID to this order. This order's gets the two products get added to this order. I think it's chicken burger at index 3 and nuggets at index 2. Uh, hmm, the third burger and the second side, chicken burger and nuggets. Yeah, right. Then toppings get added, and through toppings we can actually see how indexes, how out of bounds indexes are interpreted here. First, we add valid toppings to the valid burger, which is 2 onions for extra patty. Then we try to add the 0, which doesn't exist, and then we try to add to the 0 burger, which doesn't exist. And in both cases it says invalid product index. And the third case, edge case, is to add the second topping index to the second burger, which does not exist as well. The second burger, not the index. And it says that we failed to add a topping to the burger since it doesn't exist. Then the topping gets deleted at the second index, but this index is for the order, so it actually deletes this, not this. This is for the menu, and this is for the order. In the order, we have two onions and at 4 extra patty, and in the order we have at 1 onions and at 2 extra patty. in the order they were added to the burger. Then we browse products and see that the amount of onions is one, and there are only onions, so the topping got actually deleted. And since we tried to delete 2 times, we can see that topping was deleted. The first time it said that the product index was not valid since there is no second topping at this moment. And after browsing products we can pay for it successfully. But I don't know. I think something went um wrong in this instance. And I can say, and for insert text, this we can probably catch this. That get well when actually look at it. We can also see that the ID got incremented as I restarted the program. Table checks has no column named total. Why is that? Ah, the total is not total prices. I think if we change it right like to this and we restart, yeah, I think it's this. Yeah, now payment is successful. The check is saved. The IDs got updated to 1. Let's check this again. The IDs got updated to 2 since there is actually the first check got fully what fully saved into the database, and we can only access it if we know its ID and can no if we know its ID, since there is um, a function to access it through. No, there is no function. So yeah, we can't access the checks since we have saved it, and it's great since we can actually uh, create then a read-only programs so that it can access the check in read-only format. Yeah, I think this is pretty much it for the program. Thank you for your attention. Goodbye.